Hi everybody, the purpose of this video is to go over section 2.4, and in this section we are going to solve a more general form of a linear equation. Ax plus b is equal to c. So here we have two terms, one has a variable and one is just a constant. We are going to talk about solving linear equations that have integers for a, b, and c. Linear equations where a, b, and c happen to be decimals, and yes, linear equations where a, b, and c happen to be the dreaded fraction. Okay, so what is our goal? Our goal, as before, is always the same, is to isolate x. Or if x is not the variable, whatever the variable is, we want to isolate that variable. If that variable is bad, we want to put it in timeout and everything else on the other side of the equation. How do we do that? Any way you want. The only requirement that you have is that you need to maintain the equality, which basically means whatever you do on one side of the equation, you have to do on the other side of the equation. That's how we maintain the equality. Of course, we do have tools available for us. The first one is simplification. That is where we can combine like terms. Now, what are like terms? Like terms are those terms that have the exact same variable and the exact same exponent. For example, 3x cubed and 5.6x cubed are like terms. Same variable, same exponent. However, 3x cubed and 5.6x squared are not like terms and cannot be combined. Why? Well, even though the variable is the same, they have different exponents and you just can't add them up. For the first set, we could add this up to, we could combine these to come up with 8.6x cubed. We cannot do that here. Okay, then we have the addition principle of equality. And the addition principle of equality is the tool that we can use to move terms from one side of the equation to the other. For example, this is a term, and that is a term, and that is a term. We could use the addition principle of equality to move that b over here. And how can we do that? Hey, we subtract b here, it goes away. Remember, we had to do the exact same thing on the other side. We subtract b here. And then the other tool is the multiplication principle of equality, which we would use to move the a to the other side. And then finally, we have this thing called the distributive property. Now, if you don't recall what the distributive property is, it is this. If you have a value multiplied by a sum of a value a sum of two values enclosed in parentheses, distributive property tells you that this is equal to a times b, the product of the outside value in the first term, plus a times c. What we're doing is we're distributing the a to the b and the c, hence the word distributive property. So these are the tools that we have. Now, even though I told you you can do it any way you want, there is sort of a procedure that you might want to follow to help you solve some of these problems, and here is a recommended procedure. First thing you want to do is you want to simplify your equation so it looks like this. Now, it turns out you may not get an equation that looks exactly like this. Some simplification, i.e. combining like terms, might be required before it looks like this, so you might have to do that. Now, if your equation has fractions in it, then you might want to multiply the entire equation by the least common multiple of all the denominators. Why would you want to do that? Well, because then the denominators will go away and you will no longer have fractions. If you don't know how to find the least common multiple, don't worry. There's other things that we can do to work around that. It just might require a couple more steps. Okay, then we want to use the addition principle of equality to move terms. Specifically, we want to move the b from one side of the equation to the other. How do we do that? Hey, well, we subtract b here. If we do that, hey, b goes away. B minus b is 0. Well, if we're subtracting b here, we got to subtract b here as well. And if we do, this is what we're going to have. We are going to have ax is equal to c minus b, whatever c and b happen to be. That was kind of poetic, if you ask me. Okay, so there we are. Now notice that we have an x with an a over there, and we need to get rid of that a because we want x by itself. How do we do that? Well, notice that it's a coefficient. There's multiplication here. So that probably means we need to do some form of multiplication. And that's the idea behind it. We want to use the multiplication principle of equality to remove that coefficient. And this is really the most important part to understand about this idea here. We use the addition principle to move around terms. We want to move around terms until we have something where we have a coefficient times the thing we're trying to solve is equal to something. Once we get that, then we will use the multiplication principle to get rid of that coefficient. How do we do that? Hey, divide this side by a. A divided by a is 1, or we're just left with x. Once again, if I'm going to do that on this side, got to do it on the other side. And once I've done that, then I will have x by itself, which I'm looking for, and that's going to be equal to c minus b over a. And if we actually had numbers for these, we could figure out what they are. And finally, of course, we want to check by taking this answer, substituting it back in for x, and seeing what we get. Hopefully we will get c. Always check your work, particularly when you have the time. Okay, and that brings us to a couple of examples. And here is our first example. We want to solve this equation. Negative 26 is equal to 2y minus 14 minus 4y. And what you'll have noticed is that this is not in the correct form. It is not in the form ax plus b is equal to c. And we need to get into that form. And we need to get into that form. So the first thing that we are going to want to do is figure out where my pen is simplify. Particularly combining like terms. Well, what like terms do we have? Well, remember, the like terms always have to be on the exact same side of the equation. I think I forgot to mention that, so I'll mention it now. Well, here I have a 2y and I have a negative 4y. This is a y to the first power, a y to the first power, so we have the same variable, same exponent. They can be combined. And what is 2y minus 4y? Hey, that's 2 minus 4, or negative 2y. We still have the negative 14 minus 14. Of course, that's going to be equal to negative 26. Okay, now we are simplified. Now, it is true that this is looks more like c is equal to ax plus b, but that is really okay. We can still work with this even though the equation is kind of flipped. If this does bother you, what you could do is just basically just flip both sides of the equality. So if you wanted to, we could write this as negative 2y minus 14 is equal to negative 26. It's not necessary, but if you're comfortable with this orientation, there's no reason why you can't do that. Okay, so now we need to move terms, and that implies addition. Remember, we want to get the term with the variable by itself, so we need to move the negative 14 to the other side of the equation. How do we do that? Well, I want to add 14 here, plus 14, okay, because these will cancel out. And remember, what I do on one side of the equality, I need to do on the other side of the equality. So I'm going to add 14 here. And what happens? Well, negative 14 plus 14 is equal to 0. Negative 2y plus 0, that's just negative 2y. And that is going to be equal to negative 26 plus 14. That better be 12 or I'm in big trouble. Actually, it will be negative 12, not 12. Okay. So now look what we have. We have y multiplied by some coefficient is equal to negative 12. So now we want to remove the coefficient, and that means using the multiplication property of equality. Okay, and to do that, to get rid of that coefficient, we need to divide it by negative 2, because negative 2 divided by negative 2 is equal to 1. Okay, I'm going to do the exact same thing here, negative 2. All right. Negative 2 divided by negative 2 is equal to 1. And that just basically means we're going to have 1y or just simply y. I could write that as 1y because this is 1. But we all understand that we can also just write that as y. All right. And over here we have negative 12 divided by negative 2. If you don't know what that is, that's why God made calculators. And if you did that and you were careful with your negative signs, you would get 6. You will have the y is equal to 6. And that is our answer. How do we know? Well, we can check. Let's put in 6 for y on both of these, and if we do, we will have 2 times 6 minus 14 minus 4 times 6. Well, that's going to be 12 minus 14 minus 24. 12 minus 14 is negative 2 minus 24, and that is negative 26. So it does indeed check out. And that brings us to example number 2, where we have decimals. Decimals aren't that bad. We could be the procedure is pretty much the same. Just had to be a little more careful with our math. Once again, we have some simplification that we can do. Okay, so our first step is to simplify. Combine like terms. Do we have like terms? Well, yes, we do. This one has no variable, and this one has no variable. And it turns out that 16.53 minus 7.43 is 9.1. So we will now have negative 18.2 z plus 9.1 is equal to 0. Okay, now we need to move this term over here. So we want to move terms. And that means using the addition principle of equality. What do you want to do? We want to subtract 9.1 over here, because that will give me 0. But once again, if I'm doing it on this side, I need to do it on the other side. So minus 9.1 here. I can draw my magical line. I'm going to do this vertically. 9.1 minus 9.1, that is 0. I'm left with negative 18.2z. Put a line there, that way you know it's a z and not a 2, given my handwriting. And that's going to be equal to negative 9.1. And then finally, we want to get rid of the coefficient, and that is using the multiplication property of equality. Okay, and that means that we want to divide this side by negative 18.2. Okay, and if we're going to divide this side by negative 18.2, we want to divide this side by negative 18.2 as well. Oh, let's make that a 1. There we go, 18.2. This obviously will cancel, and we'll be left with z. And then negative 9.1 divided by negative 18.2 is going to be positive 0.5. And then finally, we want to check. And how can we check? Well, let's just go ahead and put 0.5 into 18.2 there. That will give us 16.53 minus 18.2 times 0.5 minus 7.43. Well, doing this multiplication, remember your orders operations, you do multiplications first. That will give us 16.53 minus 9.1 minus 7.43. And guess what? 16.53 minus 9.1, hey, that's 7.43. 7.43 minus 7.43 is equal to 0, which is what we have right there. So cool, that works out. And that brings me to my last example. And it is the dreaded fraction. Ooh, evil fractions. Okay. And the first thing that we want to do is, but the procedure is still the same. We want to simplify, basically combining like terms. But since we have fractions, we actually want to get rid of the fractions by multiplying the entire thing by the least common multiples of the denominator. And what is the least common multiple of the denominator? What is the least common multiple? It is that number, the smallest number that has both 2, 3, and 4 as a factor. Okay? And it turns out that number is going to be 12. So the least common multiple of the denominator is going to be the number 12. And why is that? Well, because 2 times 6 is equal to 12, and 4 times 3 is equal to 12. Okay, all of these 12 is the smallest number that has 2, 3, and 4 as factors. Now let's suppose that you had a collection of numbers and you could not figure out what the LCM is. What would you do? Well, what you can do, if you don't know what this is, what you can do is multiply the entire equation by the product of all the denominators, which would be in this case 2 times 2 times 3 times 4, which will give you 1648. You can multiply this by 48. You can still you multiply this by 48, get rid of the fractions. There'll just be a few more steps. There'll be a few more steps that you would need to do to solve the problem. But let's go ahead and multiply this entire thing by the least common multiple, which is 12. So I'm going to multiply this side by 12, and I'm going to multiply this side by 12. So now what happens when I do the multiplication? Well, I'm going to have 12 times 1/2 x plus 12 times 3/4 x plus 12 times 7/2 minus 12 times 2/3 x. And that's going to be equal to 12 times 0, which is 0. Okay, so how do we handle these? Well, look at this. We can do this as follows. We can do 12 times 1 divided by 2. That's going to give us 6. Here we can do 12 times 3, which is 36. 36 divided by 4 is 9. Twelve times 7 is 84. 84 divided by 2 is 42. And then finally, 12 times 2 is 24. 24 divided by 3 is 8. And pay attention, then a minus sign there, so this will be minus 8x. And all that's going to be equal to 0. Once we've made it this far, we can simplify by combining like terms. What like terms do we have? Well, notice here we have a 6x, a 9x, and a minus 8x. They can be combined. 6 plus 9 is 15, minus 8 is 7, and that will leave us with 7x. And then we can bring down to 42, and we have 7x plus 42 is equal to 0. And so this is all simplification. And of course, it's a little involved because, once again, we have to get rid of the fractions. Once we made it this far, now we're to addition because we want to move this term over here. So we're now to addition. We want to move terms. So that's addition. And what do we want to do? We want to add 42 to both sides. No, we want to subtract 42 from both sides of the equation. So we want to subtract 42 here. We want to subtract 42 here. And if we do, these conveniently cancel. We have 7x is equal to negative 42. Let me bring that up here. 7x is equal to negative 42. And then finally, we want to get rid of the coefficient using multiplication. So I'm going to divide this side by 7. I'm going to divide this side by 7. 7 next divided by 7. Well, 7 divided by 7 is 1. We are just left with x. And then negative 42 divided by 7, that will be negative 6. And our final result will be that x is equal to negative 6. Let's see if that actually makes sense. We will, to check, we will have 1/2 times negative 6 plus 3/4 times negative 6 plus 7/2 minus 2/3 times negative 6. All right, well, 1/2 of negative 6 is negative 3. 3/4 of negative 6, well, negative 6 times 3 is negative 18. Divided by 4, that actually is going to be equal to negative 18/4 or negative 9/2. Yeah, let's do it like that. All right, plus 7/2. minus 2/3 minus 2/3 times -6. That is going to be -6 times -2, which is positive 12, divided by 3 is positive 4. Okay, now unfortunately we have this nasty little fraction here, but -9/2 plus 7/2 is actually -2/2. So we will have -3, -9/2 plus 7/2, that's going to be -2/2, plus 4. Well, -2/2, 2 over 2, that's just -1. So this is -4 plus 4, which is equal to 0. And so it does indeed check out. And that is all I have for this particular lecture. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.